Well, today I will talk to you about this fileless malware, which is a brand new kind of malware that we expect to meet in the wild in this year and in the next years. The characteristic of this malware, as the suggestive name tells us, is that this malware has not file to be searched in the infected machine. So it's a kind of ghost malware. But I think we all agree that ghosts don't exist. So even ghost malware doesn't exist. Well, what is a fileless malware? A fileless malware is basically a malware that is stealth in practice. And it is stealth because it is located in cavities where the anti-malware does not look in. Usually, fileless malware use tools which are natively used by the host operating system. So for anti-malware, there is not anomalous behavior when fileless malware is running, because what the anti-malware or the defensive software looks is just a normal and usual software running on the machine. And another common characteristic is that the payload is dynamically executed on the target machine. So this means that the payload is not on the machine, and when the malware hands running, the payload is removed from the machine. Which are the benefits? The first benefit is that this malware is completely silent. So we know that usually malware wants to achieve two goals. The first is to be undetected, and the second one is to be persistent. In fileless malware, what we see is that these malware pay with persistence the fact that it is stealthy. And this happens because basically you have no files that can be detected on the machine after the execution. Another interesting and dangerous characteristic of this malware is that we have a lot of post-exploitation frameworks that can be used for injecting this malware in the processes running on the machine with very famous software like Cobalt Strike, Metasploit, and Empire. Which are the steps of a fileless infection? So the first step is the traditional one. So first, the malware reaches the target machine, and the target machine is usually compromised with the traditional techniques, let's say social engineering-based techniques. Then we have post-exploitation phase. And this is the core of the fileless malware working. Fileless malware exploits basically process hollowing, DLL injection, privilege escalation. Basically, these are very new techniques. These are very known techniques. These techniques are not so new. They are very old. They are in the wild since some years. But what these techniques have in common is that all these techniques try to hide the malware execution behind the execution of a legal process. So the idea is that when the anti-malware analyzes or looks at what is happening in the machine, the anti-malware just looks legal processes running. Persistence. Persistence is the most difficult part for the fileless malware, for now. In order to be persistent, the fileless malware leverages registry keys, and we have a lot of examples of malware that are written in registry keys. The fileless malware uses GPO, Windows management instrumentation, or lateral movements. Lateral movements for fileless malware are very important. We can say that lateral movements for fileless malware are important for survival, because after execution, fileless malware disappears from the target machine. So in order to survive, this kind of malware needs to spread out in the network and to infect other machines. How a fileless malware attacks? With the well-known in-memory techniques. So the malicious payload is directly loaded in memory, executed. So it's very volatile, very volatile. And of course, it's very difficult to write a fileless malware, but as I told you before, we have already a lot of frameworks that we can use for doing this kind of task. We can also meet some malware that uses specific scripts for being executed. Sometimes these scripts are also known as agents. Agents are software that are installed on the target machine before the infection and that collaborate with the fileless malware infection and execution. Usually, agents have a legal behavior, so they are not suspect software. Then we have dual-use tools. Attacker uses tools already available in Windows, of course, like PowerShell. PowerShell is the key software tool used by fileless malware at now. And it's very powerful because PowerShell is the gate for have access to a lot of software and a lot of resources on a Windows machine. Or we can have both the methods. So we can have script, the agent, and a legal tool. In-memory attacks are not new. In-memory attacks, we met these kind of attacks in very old malware in the history of computer infection, in Code Red and SQL Slammer, in Eternal Blue, and as we know, we have Kit Angler, which is a framework that is specialized in this kind of attacks. Of course, this is a not persistent attack, because when the process hands running, it disappears from the machine. Persistence is achieved with basically these kinds of technique. Malware can be placed in registry keys, or PowerShell can be used. Usually PowerShell is used after having downloaded the malicious payload and then directly executed on the machine. Scheduled tasks are also used in order to make the malware survive after the reboot. And then, of course, group policy objects are leveraged in order to open backdoors on the machine. Because another characteristic of malware fileless is that when the malware arrives on the target machine, it begins to download further components and further new malware on the machine. This is the case of Kotver, for example. Kotver was a malware that downloads a lot of further malware in the machine. Different malware belonging to different families. And we have already a lot of exploit kits that can be used for writing this kind of malware. So the situation is pretty worrying. As an example, I bring Rosina. It appeared in 2015, and in 2018, it evolved in a brand new version. And it is a very important point, this one, because malware files have much more opportunities of evolution than the malware before, because these kind of malware are not detected easily. So malware analysts don't know exactly how much malware files is around. How it works, basically, AnglerKit allows to install a DLL, and this DLL is through process hollowing injected directly in memory and executed, and the malicious payload was added to the Explorer process. And so what you see in the machine is just the Explorer process running, not Rosina. Further malware is downloaded. And then, after 3 years, Rosina appears again, in another form, with another mechanism of infection. Of course, Rosina uses PowerShell. And of course, Rosina is a command and control, and it uses Meterpreter. So, as an example of a fileless malware working, in my laboratory, I developed a fileless malware for Android devices. Basically, we make use of an agent. The agent is an app for sharing pictures. So it's very amazing to use this app, because this app uses Wi-Fi Direct, so you can throw your pics to other devices in order to exchange pics. The point is that our malware is a pic. Our malware is not a code, it's a picture. What we do, we produce malicious pictures that are basically comments for the target machine. And the machine, when it receives the picture, executes the command. It works like that. We write shell command. We inject shell command in a picture with the steganography. And then with our agent, which is a social application for sharing picture, these pictures are spreaded through a lot of devices. Of course, we do not share this agent, and of course, we use that only in our laboratory for demonstration. And this is the app for injected command. In this case, is reboot within a pic. And we choose this pet pic, which seems to be not harmful, but indeed it is. And now the pic with the malicious command is ready for being spread. And with this app, we can verify that an image contains a command. And as you can see here, you can see here that our app demonstrated, confirmed us that this PIC has this command. And this is how the fileless malware works in practice. So what you see here is the master, and these two are the victim devices. So what you see here is that the master will send, with this social application, the picture to these victims, and of course the malware will run and will do some damages. So first, our operator chooses the PIC. The pictures is a black pictures with a label, a white label. The label represents the malicious command. In this case, we have the screen record. As you can see, the PIC is already is just spread out in the network of victims, and the screen is recorded, and the video is saved in the memory of the smartphones. It's pretty fast, but you can find the file of the video. Okay, the second PIC is delete file. So when this PIC arrives to the victim device, a file is deleted. We delete just the video that we have recorded previously, and as you see, the video now is not there, and now the reboot. As you can see, the two smartphones are rebooted. What happens? In this scenario, we used an agent, which is a social application, and it is not that malicious because it is an application for sharing pictures. And as a matter of fact, VirusTotal barely recognized that this application has something strange. In fact, 1 out of 58 anti-malware recognizes that there is something strange in this application. And this anti-malware, the first anti-malware tells this perhaps is potentially dangerous, but I have no idea if it is dangerous, of what kind of software it is. And these are the PICs, these are the commands, this is the malware, this is the fileless malware. And there is no anti-malware that recognizes that our pictures are malicious. So, which are the conclusions? The conclusions are, fileless malware is a problem. It's a serious problem that we have to face today, in the near future. And the point is that the idea of fileless malware basically is, I can spread malware that does not leave traces on your machine, and you cannot detect this malware, and that our methods for detecting and recognizing malware are not effective with this kind of malware, as I demonstrate with this exercise in laboratory. And we have a lot of frameworks for implementing the techniques that the fileless malware can use in order to execute malicious payload. So we have a problem. We have to face and to fight against this new threat. Thank you.